Hello everyone, welcome back. Today I would like to go over section 2.1 and 2.2. And I would like to start now by sharing my screen and open up the PowerPoint that I would like to go over, which is 2.1. 2.1 and 2.2 is kind of long, so I only combine two sections. But the next video, I would like to combine three sections, which is 2.3, 2.4, and 2.5, because it's kind of short. And so let's start. For chapter 2, you'll see it. So for chapter 2, you will learn about picturing variation with graphs, which is you will learning about how to predict and estimating we call standard deviations or the variation between the data. And you will learn how to look at all kind of graphs, and by different kind of you can using technology. I can run some technology in StatQuant for you to look at, and or you can using TI-84, or you can draw by hands. And here, mostly what I want, I'm not focusing on like teach you how to graph it by hands, but I think I would like you to be more learning about interpretation, look at the graph and interpret it. Okay, so let's start. Okay, let me see, I'm having trouble right here. All right, so let's jump to the next slide. So for overall chapter 2 topics, you will learn about visualizing variation in numerical and categorical data. So you will also learn summarizing important features in numerical and categorical distribution. So the word distribution here is mean they're talking about the entire graph. There will be a lot of data combined and make it become a beautiful graph. Here you see visualizing variation. So you will look at the graph, different type of graph, in order to learning about, like I told you, the standard deviation, S, small s, or sigma. So right here, we got two type of variable right here, numerical and categorical. So for numerical, they have specific graph represent for to use to apply all numerical data on those graphs. And we have categorical data. They also have specific graph that you will see it. And for categorical data, the specific type of graph will be fit for this categorical data. Section 2.1, visualizing variation in numerical data. Okay, so now we're focusing on numerical data only, okay? Exploring a distribution of numerical data, and you will learn those the following type of graph. You learn dot plots, frequency or relative frequency histograms, and you will learn about stem plots. So this three type of graph will be the graph represent for numerical data. So most all numerical data, they were using this type of graph: dot plot, histogram, and stem plot. Actually, there will be more, but right here, we only focus on three types. So what is a distribution? Okay, so I tell you a bit about distribution already. But right here is more in detail about what is actually a distribution. So we call any collection of data will have variation within the data. Okay, the word variation here is like how much apart between each number, each data. So the most important tool for organizing the variation in data is called the distribution of the sample. There will be three main components of a numerical distribution. The first things, when you look at the graph, you should look at for the shape. For the shape, actually they have, so here for the shape, what does it look like visually? So for the shape, you will see many type of shape. You will see, is it a shape bimodal or unimodal or uniform or skew. So what those words means, you will see later. I will show you later. So just keep in mind that the key word for shape would be unimodal, bimodal, uniform, or skew. Okay, skew, we have two types of skew. Skew to the right and skew to the left. So totals look like the main shape is like about 5 right now, right? Center. So center is the middle, right? The mean of the whole distribution, or the median of the whole distribution. So, but in this, I given you the overall picture for both categorical and numerical data, because later I will go deeper in detail than you will kind of familiar with the word that I just said right now, so that you will know how to apply the correct word in each of the type of the data, all right? So variability. So variability all the time, they looking for the horizontal spread, which is because the graph all the time is like, look like mountain shape, like a one mount or two mounts, or evenly, or like skew. Then usually we all look at our data horizontally, not vertically, okay? So here we are focusing on the word variability. It means you're learning about the spread horizontally, right? So remember these three components: the shape, what is the center, and the variability. Is it strong or weak, or is it spread a lot or shrink in near to the center? So those type of questions you can write out or keep in mind for now. You will understand a lot when we're moving along. Distribution example. So here are some raw data from the National Collegiate Athletic Association, NCAA, available online. So this set of the data show the numbers of goals scored by first-year NCAA female soccer players in Division 3 in 2012 season. So they're having the following number: 9, 11, 11, 11, 11, and so on. The total is how many? You can count, or let me see, we can count right here. We got 2, 4, okay, let me see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and I think it's more than 20. However, right now you don't need to worry about the count, but you need to worry about, like, for this set of data, what graph will they use? Here, this data will be numerical data, so the graph that they can use for this data can be what? At the beginning of the slide, I talked about this already, which is dot plot, a histogram, or stem plots, right? So there's three main type apply, three main graph apply for numerical data. And right here, they say, note that distribution record all observed data value. So this are all the observed data. And another word they call this data will be called sample, okay? So seeing the patterns in the raw data may be difficult, right? When you look at this list of data they write, you know, just like a list like this is very hard for you if they don't organize, okay? So even if they don't organize for you, for this set, look like they already organized for you already. So it's kind of easier, you know, like they got 9 and the goal is 9, 11, 11, 4 times. It's easier for you to read like that, but it's still hard, correct? So in order to make this data set visual, so they use graph or they use table. So let's go each type of steps so that you can compare. Okay, so let's look at the next slide. So for this slide, they look like they are making the table, and they, you know, given us the idea how to listing out like the value column and frequency column right here. So the value is all the goal numbers, and the frequencies mean like how many times that they got it. So right here for 9 goals, right there, only 1 time, and 11 they got 4 times, and so on. You see that? So this table is kind of it's easier than the first slide, right? Then this list is kind of easier. This one is harder to see compared to this table, correct? So now let's check it out. The next picture. So before I jump to the next picture, I would like to explain a bit the word frequency. So frequency is the number of the repeated patterns, okay? So right here, a frequency table lists all the data value with their counts. Patterns may be still be difficult to see. Okay, so it looks like they still kind of not satisfied with this kind of setting. Okay, that's fine. It depends on each person. If you like this, that's okay. You don't have to follow another person idea. Okay, so we call this is frequency table, and frequency is the number of the pattern of that value. So let's check it out, the next one. Let me see if they have different ideas about how to set up the data about the goal of those female. So when examining distributions, use a two-step process. Visualize the data. So in order to make the data easy to read, so they said use the graph that effectively summarize the data visually. This means they're using the graph. And there are 3 main type of graph that I told you is stem plot, histogram, and box plot, dot plots. I'm sorry, dot plots. So using a picture to display the data will help us to see pattern. Sometimes people graphing is one thing, but they make colorful to see the data easier. Graph for numerical data including dot plots, histogram, and stem plot below here. That's a 3 type of graph to make data visual. Second, summarize the data. So in order to summarize the data, so the first step for all kind of numerical data, first you should graph, okay, by using 3 type of graph that I just mentioned earlier. Second, you need to analyzing the shape of the graph, center of the graph, and the spread of the graph. For the spread of the graph, when you look at a graph, you can kind of roughly estimating it, or using StatQuench or recompute by hands. So later section, you will see the formula to teach you how to figure out all of this type, all of these three components right here. For the shape, they putting the question for us is the shape symmetry? The word symmetry is mean the graph will be, you know, when you cut the graph in half, the left and the right side have to be roughly equal, okay? Roughly like kind of the same thing. We call symmetry. But like I show you, the shape can be five specific shape. For symmetry, symmetry is one of the shape talking about we call unimodel, okay? And so here they just put one question, but if you understand later, the next slide, you will see hopefully you can see all type of shape. Yes, I believe so. So you can understand what I'm talking about. So, and we have a bimodel, which is two mount. So for symmetry, we call unimodel, and for unimodel is only have one mount shape, right? And we have uniform, we have skew to the right, skew to the left. So those kind of shape so you need to look at a graph and determine. For the center, the question good to answer for the center is you need to answer this question: is there the most common value? So it means like which data will be the most having the most frequency, okay, or the most common. The most common, like they have the value close to one another. For example, the 21, 22, 23, they kind of close to each other. So you can easily estimating the value by taking the average or estimating all of the common value. The spread or any data value far from the rest of the data. So here the spread is here mean like if you found the center already, which is the majority of the data, going around with those data, like the example that I said, 21, 22, 23. So let's say talking about the number of maybe the ice cream that you eat for a year, for example, 21, 22, 23 ice cream, stuff like that. So if the spread that you can notice in the data set, then you will see the data will get close to those data, common data, or it's kind of spread all the way out. Like some people eat 10, eat 5, 6, 7, and other people eat like 35, 40, 50, stuff like that. So they eating ice cream like kind of different number. So that the number that I just give it to you is kind of spread out a lot. But sometimes the data set can be like close to each other, like 19 is the smallest, like a couple of people eating 19 ice cream, and a couple of people eating 20, more people eating 21, more people eating 22 and 23, and a bit going down, like 10 people eating 24 and 25, stuff like that. So those kind of set of data, they having a strong spread, which is it look like all the data value kind of close to each other. So it's representing the spread is very strong compared to the from first example about ice cream that I talked about. So it's kind of like that. But don't panic, because later we will have a lot of example relate to this one, and you don't have to worry about it too much. But please all the time keep that in mind and understand every single slide as you can. So visualizing data the goal is you keep in mind using the picture to display the data will help us to see the patterns. So different visual presentation capture different aspects in the data. So the picture must record the data value, yes, of course, and indicated the frequency, the count of the data value, which is mean all the graphs should have the vertical line, vertical number line and horizontal number lines, so that you can see the value horizontally and vertically. Look like this. Okay, so this is a dot plot. They look using back the example we talk about the goal. So this is the table, frequency table, and they're using this data by make it visual by using dot plot. So when they make it become dot plot here, what does it mean? Let me help you how to read this. For this dot right here, you see that below number 10. It look like, so that you can estimate this would be number 9. So look back here, number 9. We only one frequency. So now this next 4 dot right here. So got 4 dot, they stack up, right? Please don't overlap it so that you can count easily. So this 4 dot is look like its value will be number 11. 11, 4 dot right here. So each dot represents for one individual, okay? So and so on, and you see the dot all the way over here, 35. 35, how many pattern? 1, but 1. But it looks like this dot is far away compared to this data right here, right? So because of this, this dot have a name. We call outlier. So let me annotate this for you. You will learn this word later in the later section, okay? So this we call outlier. So I'll let you know ahead so that you can get familiar with the word that I'm talking about. Outlier. I'm sorry, my pen is kind of bad. So it's an outlier, which is this outlier represent for this outlier usually screw off the whole distribution. It make us have a bit difficult time to estimating or to find the exact mean or median or the center, okay? So usually some people, instead they cut it off, that outlier, so that they can estimating better. However, let me see. However, right now, we learn how to read it only, so we don't have to worry about this outlier. But here, because of this, I can estimating the spread is kind of not really strong. If we cut off this outlier, we erased it, and you can see this data set on the left side right here, very strong, okay? Which is the value of the variation is small, okay? The small is the better, okay? All right, so let me jump to the next slide. So here is another example. So this example talking about the college bookstore. Right here you can see each dot represent for one price, okay? One price of the book. And all the way you can see there one book is very expensive right there. It's almost $300. And most of the book is they running around like they less than 150, right? Or another word, I noticed like book is focusing on here and below here more, right? So for the spread, kind of similar to previous example, because of this outlier right here, it make us estimating the center is kind of hard. The center is like the typical value is represent for the entire books. Like the average, another word is the average of the book. Okay, so right here they have some question. How many textbook cost 150 or more? So when you are having this graph, you can easily answer this question. So you look at 150 right here, but they want to asking from 150 and more. So you can count at 150 is 1, next to it is 2, 3, and 4, total 4 books. What percent of the textbook costs $50 or less? So $50 or less. So you look at the word, the number $50 right there. So they count 50 and then go down. Got 1, 2, 3, 4, 5, 6, 7, 8, right? Total 8 books. So in order to figure out what percent, you have to take 8 books here divided by the total of the book. Since here this book is very expensive, that's why it's kind of is a bit hard for us to estimating the average of the book, but it's okay. So if we answer that question, you will take 8 divided by the total. So you need to count that and you got a value. Remember if you hear the asking for percent, it's nice that you can multiply by 100%, but again, personally, I'm okay with fraction. Next question, are there any unusually expensive or inexpensive tax? So inexpensive tax usually like close to $0, right? But it looks like all the data kind of spread okay, like evenly. Especially this 300 is kind of very expensive. So this is unusual. So like I said, the word for this will be outlier. So this value is, we call an outlier instead. So here is the solution. We got 4, textbook cost 150 or more, and 8 divided by 23 times 100% is roughly about 34.8%. Cost $50 or less. And the textbook that costs close to 300 is considered unusual. Right? The advantage and disadvantage about the dot plots. So here is for you to know that what is the advantage and disadvantage. Advantage that they show individual data value and it help investigate the shape of the distribution. I think all other graphs, they help investigate the shape of the distribution too. For this advantage, it's not common. Like not a lot of people using the dot plots if they compare to histogram. A lot of stat people are industry, they're using histogram more. And not great for data with too many individual value. Yes, for histogram, people can use like 1,000 or million of the data, that's fine. But for dot plot, they cannot do it. If they have 1,000 data, they should not use the dot plot. They don't have space for it. So it's the disadvantage thing. Visualizing data. So let's talk about histogram. So histogram, you have 2 types. We have a histogram with frequency and histogram with the relative frequency. But actually the way that we do it kind of the same. It looks the same. So let's talk about histogram. Histogram help us to group the data into intervals. The word intervals here, they are having the lower limit and the upper limit, or another word, the low value and the high value, okay? And they grouping data into columns, okay? So later I will teach you how to read it. For the next slide, if they have the picture, then I can show you. And they call that will be bins. So this bins is the width of the interval, okay? All people will call it bin width. Bin width is depend on the data is it the data a lot or the data is not too many. If it's too many, then the width can be classified kind of large. But if they are having like about only 20 data, if they form as histogram, usually the bin width about 3 or 4 or 5. Okay, so but they have like 1,000 of the data. They will group the data with the bin width is large, very large, like 20, 25, 30, stuff like that. It depends. And for histogram, count how many data value falls into each bin. Okay, yes, each interval you will count. You need to count the data if the data if the observed data falling into that interval, then you count the observed data and put them into that bin. Okay, each rectangle. So this rectangle is the box, like the column, like the box, the rectangle that I'm talking about, has the following properties. Consecutive bins touch. Okay, actually it should. Most of histogram all the time, their bins are touched. However, sometimes we are having some data, the bin is not touched. Okay, for example, if the bin is very small, like about 0.5 or 0.7 or 0.8, 0.9, stuff like that, they don't touch. But most of the histogram, the bins will be at least including like the whole number 1, then it can be touched. And again, it depends on the data, but 95% of the data, all the bins have to be touched. Okay. So first value in each bin is recorded on the horizontal axis. The height of each rectangle corresponds to the count. Another word, the count is the frequency. Okay. Okay, let's move on to the next one. The next picture is the picture about histogram, and we can read this. Let me show you how to read this one. So here is the same example as you using this for dot plot or frequency table, right? But this time we're using the same table to like graph as in the histogram. So look at this. So the vertical column we call the frequency. So the frequency here. So all the value, remember when you scale, look at here is 1, 4, 1, 5, 3, so on. So the frequency depend on how do you group the value in the bin, then you have to accumulate those. Here, we are estimating the frequency up to 9, okay, and why? So let me explain a bit down here. Let me analyze this picture for you. Again, the histogram, they're saying that all the bins should be touched. So that is touch, all the time touch. But then this box is not touched. Because why? Because this bin, including what value? 35. So this bin, the interval is from 33 to 36, right? It looked like from 33 to 36, but actually, because you look at every bin width, they are equal. For example, you take 36 minus 33, you got 3. So 3, they differences between 3 value, which is if the observed data from 33, 34, 35 those values will be included in this bin. They don't count 36, okay? If it's 36, then will be more column. But here, the maximum we are having is 35. So this 35 will be stay in this bin. So only one value. So they said frequency is number 1. See that? Only number 1. Then we're done with this box. So but usually they draw from the left to the right. But I analyzing the right first because it's very like easy and obvious. So I explain that first. So now let's go back to at the beginning. So the minimum value that you notice is here is 9, right? But then you are wondering, like, how do I know how many bins that I should create? So it looks like this. You can create, so let's say number 9 right here, 9, and then 10, 11, and 12. You can create 3, the bin width can be differences like 3 number. For example, if you start with number 9, you put number 9 right here, and you want to include number 11, number 10, stuff like that, will be in the first bin, then you should create the bin, the interval will be 9 to 12. What does it mean here? It means this first bin, all the data from number 9 to number 11 will be all grouped in this first bin, not number 12. Number 12 will be counted the next bin. And that is the way that they read histogram, okay? So when they read histogram, they only read from the left. They include the value on the left, but they don't include the value on the right. So for the first bin, let me count. For value 9 to 12, you only need to count from 9 to 11. Okay, so how many value 9? You got 1. How many value 11 you got? 4. The total you have to accumulate this. Or the total is 5. So the frequency will be number 5. So they draw all the way up to number 5 right here. Okay. And the next bin, so have to be all consecutively. So here 9 plus 3 is 12, 12 plus 3 is 15, 15 plus 3 is 18. You can list out this number first and then you can draw later. But in this class, I don't force you to graph by hands. You can use StatCrunch and it's very simple. Later, I will kind of roughly graph it for you. I'm not going to use this data, but I quickly using my data. So you can you can kind of understanding how to using StatCrunch to graph histogram. So next, so the value from 12 to 15, so this second bins right here will be counted from number 12 all the way to number 14, okay? Since here doesn't have don't include the decimal number, so you don't have to worry about decimal number. You just check for the whole number, 11 to 14. I'm sorry, 12 to 14. So let's count. 12, we have 1 here, right? So will be 12 included, 13 and 14 included. So let's look at all of this. They have those values? Yes. The total value, it will be 9. So the frequency for the next bin will be 9. We go all the way up. Draw it. You look at this, they draw evenly. See that? It's not like the fat rectangle or the thinner rectangle. You don't graph like that. They all have to be the same size, the same bins. So look at the next bin. So can you try it? What do you have? 15, right? 16, 17, stop. Now count the frequency from that. 15, 2, 16, 4, 17, you don't have it. If you don't have it, you don't include it. You don't count 18. So total will be 6 only. So you draw all the way up, 6, frequency is 6. And so on. You keep graphing like that. That's how you read the graph. And again, for this histogram, you can see the typical value on the center is roughly around on this side, okay? Not on here, but on this side, because what? Majority of the data is around here, okay? So maybe the median will be around here. That's what we're guessing. So we're guessing based on the pattern. That is how it's mean. That is what it's mean. And here is another picture. This picture to changing the bin width is mean if you do not like the bin width is 3 unit apart, though you can choosing like 1 unit or 2 unit is depend on you. So if you changing the bin width, for example, for this one, it look like the size of the bin is only 1 unit. See that? So here represent for number 9, we repeat only 1 time, and here is number 11, repeat 4 times, and so on. So this one, not all of the rectangle touch together, you see? They have space, they have a lot of space right here. It's fine. So in short, for histogram, you are allowed to changing the bins width. It's up to you. But depend on the data. If the data is too large, too many, you should set the bin width large, like 10, 15, stuff like that. But if the bin width is like medium, like more than 20 or 30, you should set the bin width is like about 3, 4, 5, 6, or 7. Okay, usually the common bin width is 5 to 7. Anyway, it's up to you. So all the histogram is helping us to estimating the graph, the shape. But for in this case, to me, if I graph like this, let me see if I can graph that. If you check for the shape, then I graph like this. Stop here. You see that? Okay. This we call unimodel, but skewed to the right, because we have one outlier to the right here. That's why we call a bit skewed to the right. All right. Let's move on to the next slide. So here is the notes about the bin width. A width that is too narrow shows too much detail. Too wide behind details. So it's up to you that you can estimate the correct bin width for the group of the data. So most technology like StatQuant and TI-84 chooses bin width for an initial look at the data, but one should always experiment with adjusting bin width to see if anything interesting appears. Okay. The advantage for this is good for large data sets all the time. It's how focus on the general shape of the data. Easy to spot outliers. For disadvantage, individual data values are not visible. It's lost. It means that you cannot see individual data in that bin width anymore, but you see the overall picture. Distribution shape affected by change in bin width. Yes. So here is the slide that show us how to using TI-84 calculator to do it. For TI-84 is to me, personally, is a longer step, but it's okay. So you can practice by following this step to have it, because I don't having TI-84 online, so I cannot show you, but I can show you in class when face-to-face. But you can follow this step, then you'll be fine. You enter it, I'm for sure. For stem plots, so for stem plots, also called stem and leaf plots. Other textbook they called it this name, and anyway, it's the same thing. Stem plot is like dot plots and show all individual data value, and it's useful and useful when technology is not available or when the data set is not too large. And people not using this stem plot frequently, usually they use histogram. But anyway, you should know this too. And I will teach you how to read this. So here is the data set of the how many alcoholic drinks they had consumed. Okay, in 7 days. Wow. So you see this list, they already organized for us, and you see the patterns. To create a stem plot, you need to write the one column for stem and another column for loops. Okay, and for stem, how do you write it? So you look at the data right here. They start with 1, 1, 2, 3, 4, 5, 6, 8, involving 10, 15, 20, 25, 30, and so on. So whatever the value they have, so you have to care that if they starting with the value from 1 to 9, you have to put all of those values in the stem 0, okay? And any value from 10 to 19, you will put those values in stem number 1. And any other value from 20 to 29, you will put those values in stem 2, and so on, okay? So right here, we are having from 1 to 9, we are having the observed data is from 1 to 8. So you will copy all of this data down underneath, but have to be in order from low to high, no commas, okay? No commas. If you put commas, then it will be error. So you see that here, then you can read, okay, you can count. Like 5 people drink 1 cup in 7 days, 3 drink 2 cups in 7 days, and so on. And for stem number 1, it's from 10 to 19. So let's count, you got 10, 1, 2, 3, 4, you write down 4. See, you got 2 10, 1 5, and 1 17. That's how you read it, by combining this. And so on, and so on. You see, the 0 right here is matter. Like here is saying that 2 0 is mean there will be 2 people drink 30 cups in 7 days, okay? And so on. I'm just finished section 2.1. I'm glad you can. I hope you can understand this section. If you have any question, please let me know. Right now, I would like to focus on section 2.2, summarizing important features of a numerical distribution. So for 2.1, you're already learning how to visualizing data using graph. But today, I would like to focus on how to analyzing the graph by identifying shape of the graph, center of the graph, and the spread of the graph. Or the word that you learned before is variability, right? And you will learn about the word outliers, okay? So outliers here is the word that we talked about in section 2.1 already. So let me go back to, let's see, the shape of the picture. You see it here? So here for this picture, they combine 2 types of the graph, right? Maybe bar graph combining with time and series graph, but you're not learning time and series right now. If you want to read more, you can read more in textbook. But I would like you to focus only that's 3 graph: dot plot, stem plot, and histogram. You don't have to worry about that. So here today, I would like to share with you this is Pareto chart, and this graph is like a curve graph, and this is sideways, and See, they got all kind of graph. However, like not really common. So the common is the one that we learn currently. For this one, so let's focusing on the shape. The shape there, for three basic characteristics of the shape, is the distribution symmetric or skew? Okay, how many mouse appear? Are unusually large or small value present? That's those questions that you asking, you yourself asking it. For symmetric all the time we call unimodal or one mouse shape, and this look like the left and the right side roughly the same. Okay. So when you are having the histogram, it's okay. You just tracing along to see the shape, then you can, interpret that. So this is symmetric. And this one you look like this is skew. So when you trace along the graph, you will see on the right side is more skew. Like the data is like less and less, and then it's spread out a bit longer. So this we call skew to the right because more to the right here. And the yellow picture right here, histogram, is like is skewed to the left. So you see that? There's more data like kind of skew right here, and a lot of data like repeat more up here. Actually, for this one skew to the left, it's kind of, if we are interpret that, it's kind of similar to a bit symmetric, but still skewed to the left. So classified by how many mouse are present. So unimodal, this is the name that I just keep repeating, one main mound. So this is bimodal, is two main mounds, you see? So one right here, one right here. Multi-modal will be more than two main mounds, which is more, but you're not gonna see that graph. Maybe you can see bimodal, but you're not gonna do multi-modal at all. So I just show you how to look at the graph like skew and bimodal, symmetry, right? And that is how you look at a graph and tell. So right here, let's see. Keep in mind what mouse can be different height. Yes. Bimodal and multi-modal data may indicate existence of different groups within the data. So in this case, it might be preferable to separate the data into two groups and provide separate graphs for each group. Example, men and women's high, afternoon and evening sales at the restaurant. So this is the recommendations. It's okay. For the outlier, I already taught you how to look at the data and tell it is outlier, right? So look at this graph, the outlier right here. 1,200 is right here, is the outlier. Outlier is extremely large or extremely small. It's far away from a group of the data. The data value that don't fit the pattern of the rest of the data, okay? And not precisely defined. So when you see extremely large or small value, report the value. So all the time when you got the actual data and there will be some outlier, you should report that. You should like make it report it somewhere that you will kind of notice, okay, this happened, this distribution have outlier, we have to go back and fix it, or we should remove it so that we can estimate the pattern easier, stuff like that. So realize that could be sources of error or typo, kind of helping us to, analyze more carefully. Outliers are unusually interesting data value. Sometimes Outlier can be the left side of the graph, or sometimes it be the right side of the graph. It's outlier, you know, like it's not like only one. Sometimes it's like 2, 3, 4, 5, 6, 7, 8, 9, 10, depend on how large is the data and how far of that outliers away from the pattern of the data value of the group of the data. Okay. Center. Center is a typical data value. So center can, what is center? Center is a kind of a value that represent of the whole set of distribution. So example, the histogram for division first year women and men's soccer players in 2012 are given below. So this go back to the example that we talked about in part 1, right? But they have extra for the men go right there. It look like you look at here. Look like for the women's side there are more data compared to the men's side. See that? If you look at the bin width 9 to 12, which is like three value, like three number value apart for it here. But I look at for the man, I have from 6 to 9 is also three number value, correct? So they look like they have the same bin width. But okay, we don't care if they draw like here is look smaller, here is look bigger, doesn't matter. So if you check for the bin width, it's kind of the same. But look like this for the men's side, less data. And the women's side, it looks like more data. You know why? Because they have more rectangles. Okay, that's first thing. They have the same bin width, but they have more rectangles. And right here, they have less. They only have 4. And for the spreading, it looks like, to you, what do you think? It's kind of like the women is more spread compared to the men, yeah? Because there's more data. There's more data spreading out. Here it's like less data, but they're not really spreading out right there. So the typical score that they can estimate is will be around in the middle, will be grouped on the left right here, and for the men will be around the right here. So for women, the typical value or the mean or the median will be 16. And the man, the typical value or the center or the mean or the median right here will be 13. And for the variability compared to women and men, if you compare, it would seem that the typical male soccer player score fewer goals in season than a typical female player. That's they talking about typical value, and the variation to me will be the other side. So let me analyze this one more time. Look at the horizontal. Actually, you know, here when you look at a picture, it depends on your opinion. It's not like right or wrong. Sometimes we interpret wrong. That's fine. Me too. I all the time did wrong, and then I look it back and make correction. That's fine. However, I would like to you all kind of understand that you practice back and forth. So if all the data value are similar, you got narrow graph. Like they have more data right here. If the data value are different, they will have wider graph. So they kind of got two options right there. So right here, summary, always remember to describe a numerical distribution using these three components. The shape, we did learn about that. Center, you need to learn about it. But you will learn more about this for later section. Right now, kind of leading us see the big picture first and then a smaller detail later. Variability will be horizontal spread. So that I would like to go back to this. What does it mean here? They put 2 dots right there. Is maybe they are describing this for that one. Let me see if all data value are similar. They not really tell which one to horizontal spread or to which one. It's depend on us. This one's less spread, right? They stick together more right here. There's less data and they kind of have less data and more data spread out. You can tell by the rectangle box, right? This is bigger and this is smaller. They have less data. So this one look like they have their standard deviation is bigger than compared to this one. That's what I think. Okay, so we are officially finished part 2. I hope you can catch up and understand the lecture. Please email me, let me know in class whenever that you are having question, but please watch this over and over, understand it, and you know, take note yourself, or don't try not to like sit there and, you know, let me talk and you not understand like anything. I hope you wake up all the time, every single slide. Please understand it and rewatch over and over. Thank you. See you next time.